So for the first one, where do we start off with on these always for an equation? Always the y-intercept. So for this one, that y-intercept is going to be what? 2. It's right there at positive 2. Perfect. So in my equation, 2 is added to the x at the end of the equation. Second thing I find, of course, is the slope, and that's a rise and a run. Now from here, am I going to go up or down? Down. So it's a negative, how far? Negative 2 and a run of 3. So it's a negative 2/3 slope. So negative 2/3 times x plus 2. Over here, where's my y-intercept at? Negative 6. So this is going to be y equals something times x minus 6. For my slope, from this point, as I move to the right, do I go up or down? Up. Tell me when. Okay, so how far was that? 6. Then I'm going to run how far? 3 units. So 6 over 3, which reduces to 2. So y equals 2x minus 6. 2 over 1, that would be fine. 6 over 3 would be fine. It's just poor grammar. It could be y equals negative 6 plus 2x would be fine. As long as it's a negative 6 and a positive 2x. So if I ask you, let's say I have a line that's something like this. And there's a point right here, negative 1, 1. And there's a point right here at 2, 3. How can I find the slope of that line? Well, I've got two options. I could draw in this rise and run, right? What would the rise be? 2 from 1 up to 3. And the run would be 3, right? From negative 1 to positive 2. So that's 2/3 slope. The other way I could have done that, so I could label that as 0.1 and 0.2. Then remember it's, guys, y2 minus y1, which would be 3 minus 1, over x2 minus x1, 2 minus negative 1. 3 minus 1 is 2. 2 minus a negative 1 is 2 plus a positive 1, or 3. So I get 2/3 either way. So what if I have one here? Goes through the point negative 1, 3 and 1, negative 1. Again, I could do this. What's my rise here? Negative 4, and my run is 2. Negative 4 over 2 gives me a slope of negative 2. Or I could use the points. I could call this 0.1 and 0.2. What would go on my fraction here? What's y2? Negative 1 minus 3. And then 1 minus negative 1. So what is 1 minus 3, or negative 1 minus 3? Negative 4. 1 minus a negative 1 is 1 plus a positive 1, which is 2. Negative 4 over 2 is negative 2. So we got negative 2 slope. What do you think? So if I gave you an equation and asked you what's the slope, how would I find the slope? Negative 3/4 is the slope. Very good. If I asked you to graph this, what would you do? Down 2, okay. Up 1 over 3, perfect. There's my line. If I asked you to graph this, what would you do? Subtract 4x. Hold on. So subtract 4x, it's gone. That's negative 2y equals what? 6 minus 4x. 6 minus 4x. Now we have to divide by negative 2. Now when we divide, we have to divide every piece. So the negative 2 cancels out. We have y. 6 divided by negative 2 is negative 3. Negative 4 divided by negative 2, positive 2x. Where do we start? Okay. Treat that as up 2 over 1. There we go. There's our line. What if I give you an equation that looks like this? Chances are, easiest way to do this is going to be this. Make a table, right? Let's say x is negative 3. Let's just put in some values here. If x is negative 3, what's y going to be? Well, what's negative 3 squared minus 4? What's negative 3 squared? 9 minus 4 is 5. So I've got negative 3, 5 right there. How about if x is negative 1? Negative 1 squared minus 4. What's negative 1 squared? 1 minus 4. Negative 3, right? So negative 1, negative 3 right there. What if x is 0? 0 squared is 0 minus 4 is negative 4. Perfect. So that is 0, negative 4. Well, I've got positive 1 and positive 3. If I put in positive 1, 1 squared minus 4 is negative 3. So 1, negative 3. I put in 3. 3 squared minus 4. What's 3 squared? 9. Minus 4 is 5. So 1, 2, 3, 5. Parabola. Woohoo! What do you think? Better than the sharp stick in the eye? Okay, well, I think you guys are prepared for the quiz, so... So anyway, what we're going to start out today, just to fill some time here after the quiz for the first hour, is some applications, some of these formulas. You guys, we did some stuff on calculating studs and things like that. So I want to go to the next step here and look at doing gable ends and sheeting and stuff like that. So we're not going to get into trim and any of that, but we are going to look at something like, in this packet I handed out on page 320 there, if we give you gable ends, then we need to find how much lumber we need for studs. So we're going to look at something similar to one of those. I'm going to look at a 32-foot span and a 6/12 slope. Now there are a couple of things we need, some information we need from this before we can do any calculations. First piece of information we need is the number of studs. Now we're talking about framing in a gable end. If you're not using a gable truss, in a lot of places you actually frame it in, especially if you're doing an attic or anything like that. You frame it in so it can be insulated. So you actually have a 2x4 framed gable end rather than just a gable truss that's the 1.5 inches thick. Or if you're looking at designing the gable end truss, it's going to go under pretty much the same rules. So the number of studs required to go across here is going to be 12 over your on-center spacing times your length minus 1. Why did I subtract 1? You don't need any at the ends because obviously the height at the end here is 0. You don't need a stud there. So this is 32 feet, and we're going to assume 16-inch on center. So this is 12 over 16 times 32 minus 1. What do we get for that? Try that in your calculator, see what comes out. What's that? 23. So 23 studs or 23 uprights, whatever you want to call them, because technically they're not really completely studs. The second piece, so that's the first piece of information we need. The second piece of information we need is we need the maximum height. How do I find the maximum height of this thing? This is a 612, right? Equals, we're not going to use 32, we're going to use 16. Yeah, where did 16 come from? Half of the 32. So 6 times 16 divided by 12 gives us 8 feet. So the maximum height here is 8 feet. So the length of, now we could go through and figure out the exact length of joist we need, but the length of each joist, but we're not going to do that. What we're going to do is this. We're going to take that maximum length times the number of studs divided by 2, which is going to give us 92 feet of stud material. Now here's the key. What are we going to order for materials? Well, we have to make sure we have at least one stud that's how long? 8 feet. Technically slightly less because you got top and bottom cord or top and bottom plate, but we're going to go with the 8 feet. So what we're going to do now is we're going to take the 92 divided by 8, which is going to give us 11.5. So we're going to round that up. We need 12 8-foot studs is what we're going to use. That's a framing in one end, yes. If we're doing both ends, we're going to times 2, exactly. I would do the 12 times 2 just because you're doing angle cuts and stuff like that. It could be waste. And for this one here, you could do the 8 times 23 and not divide by 2, but that would add 1 or 2 for waste just because of the angle cuts. And that is a good point. You could do both ends all at once by not dividing by 2. But here's the thing. This one at 32 feet, the center's at 16 feet, which is an even 4-foot spacing from the end, which means there's naturally going to be a stud in the middle. But if that's like a 34-foot span, now there isn't naturally going to be a stud in the middle, but you want to force it. You always want a stud in the middle, so you're going to force that to be in the middle, and then that might throw off as you go each side. Now, generally it doesn't because you'll get out here, like here, 16 inches from the end, that's only going to be an 8-inch stud. Not only is it only going to be 8 inches, but you also got the top and bottom cords there, which means it might only be like 4 inches. Probably don't need that one in there. So you usually leave that one out, those little tiny ones out. So I mean, there's a lot of adjusting. This is just for estimating purposes. And it's always best to have a little extra material and send it back because you're always going to use a little blocking and stuff like that. So be aware that, yeah, this is probably going to give you more than what you need. So like you said, Sean, if you did that where you just did 8 times 23 and left that as 90 or 184 feet and divided that by 8, you probably would be okay. Now, so there we go. We need 12 8-foot studs to do the uprights for this gable end. Now that's just for one gable end, not both ends. Second thing we want to find out, so what we did there, of course, is we did the maximum height times the number of studs over 2, because you're going from that full height down to 0, so on average your stud's only going to be half that length. And then you took that number, that result, divided by your max height. Now notice I put max height nearest length. So if that was 7'2" was your max height, you're still gonna need an 8-footer. If that was 6'3", you're gonna probably round up to a 7-footer if you can get 7-footers. We're just gonna use for our classes. We're gonna use standard lengths, 6 foot, 8 foot. We can use 7 foot because they do have 7 foot's common enough now in most places you can buy them. But we're not gonna say, oh, that's
9 foot is too, isn't it?
9 foot is not very common. Well, 9 foot, no, technically not 9 foot. It's 105 and 5/8 or whatever, or 104 and 5/8 is what it is. It's a 9 foot pre-cut stud, so it's technically not 9 feet.
Oh.
It's got the 4 and 5/8 inches taken off of it, or actually 4 and 7/8 or something like that. Did they take off of it for that? They may not have, were they exactly 9 foot or were they the pre-cut stud length?
I think they're exactly because they had glue on each end and they come up in the wall.
Okay.
On each end, so I don't think they cut them.
So they must have, yeah, but they used them for studs.
Yeah.
So they were pre-cut studs. So they were 104 and 5/8 or whatever the heck it is that they use. Yeah, that's very common to have for 9 foot walls for pre-cut studs. But to actually get an actual 9 foot 2x4 or 2x6, you don't see that. Yeah. Yeah, when you put the shoes and plates on it, you end up, it should be 9 foot 1 1/8 inch is what it should end up being. And of course, then we're always going to round up at the end of this. So let's say we have an offset one like this. Let's say this is a 12-12 over here, and let's go a 5-12 on this side. So this is 10 feet and 24 feet for an overall 34 foot span. So first, number of studs, 16 inch spaces. What are we going to do? 12 over 16 times 34. We'll just do the overall span all at once. Times 34 minus 1. What's that going to give us? Gives us a decimal. 24.5. So we're going to round that up to 25. Next thing we're going to need is the tallest, or the height. Well, over here we've got, this is 12-12, right? So we've got 12 over 12 is our slope equals blank over 10. Why don't I cut the 10 in half? Because that actually is the run here, is 10 feet, right? It's not the overall span. 12 times 10 is 120, divided by 12 is 10. That's a 10-foot height. Now, just to be safe, I'm going to double check it. On this side, that's a 5-12 slope out of 24. Cross multiply and divide, I still get a 10-foot height. So yes, this is 10 foot high. I did it from both directions just to make sure that there wasn't a screw up in the truss. Okay, so we know we got a 10-foot height. 25 studs, what are we going to do from there? Max height, 10 foot times 25 studs divided by 2 is 125 feet. And then what? We need 125 total feet for our uprights here. What are we going to do with that? Divide by the longest one, which is 10. 10 feet was our height, our overall height. So that's going to give us what? 12.5. We're going to round that up to 13 10-foot boards. Or framing units.
That's better.
13 10-footers, just 13 10-footers or 10 foot by 13 of them or whatever. It doesn't. How you express it, I'm not real picky on that. Next thing we need is gable end sheeting. So I'm going to do the gable end. Let's go back to that first one. It was 32 feet, 8 feet high. How much sheeting is that going to take? Well, it's 32 by 8 divided by what? Divided by 2 would give us the area of that triangle. But I'm going to do divided by 2 times 32. Where did that 32 come from? What's that? That's the area of a single sheet. Very good. That gives me 4. That's 4 sheets for one gable end. Now, as you said before, if you wanted to modify this, you just do 32 times 8 divided by the 32 square feet. Without dividing by 2, it would give you both ends at once. I prefer to do one end at a time and double it just because you guys are, so you can see where it's coming from. But in practice, you'll find those shortcuts yourself and just start to use them. I would rather teach you the long way to do stuff and have you guys figure out your own shortcuts once you're out in the field. So we had then this one had a 10-foot height, a 34-foot span. Do I have to do each side separately? Say no. No. It's just a base and a height of that triangle. It's 34 feet times 10 feet divided by 2 times 32, which is going to give us what? 54.4, something like that? Or 5.44? 5.3. So 6 sheets. So the question comes here. Since I am going to do both gable ends, do I double the 5.3 and then round it up to get 10.6 and round it up to 11? Or do I round it up to 6 and then double it to get 12? Because it can throw you off by a sheet sometimes too. Again, that's one of those things that will come down to you guys doing it on your own. For our purposes, we're going to round it up first and then double it. Because again, you are cutting angles, and if you're not careful, there's a lot of waste to it. Because let's go back up to this one here. A lot of people think, oh, well, I'll just go, there's a 612 slope, right? So if I go 8 feet here, I cut that sheet corner to corner, which will fit. I just take the other piece and put it over here. What's wrong with that? Anybody tell me why that doesn't work? The sheet's a rectangle, perfect rectangle. So the dimensions of the sheet will be fine. Your angle's backwards, yes. There is an inside and an outside to your OSB. If both sides of the OSB were the same, that'd work fine, but you'd have to flip it over. Now for this particular roof, you could actually slide it up here and it would fit right there with a full sheet down below. But that doesn't always work. So generally what happens is what you cut off of this sheet here, this piece that is cut off, can only be used either above it if there's enough room, if it's a high enough peak, where this one is. Most of the time it's not. Or you have to go to the other end of the building and use it on the other gable end. It just requires a little bit more material management. And some contractors have decided labor is more expensive than waste. And that's, again, a decision you would make in the field. They would just cut that off and toss it and not use it, rather than have someone carry it down to the other end of the house and figure out how to make it fit. So again, those are things that you'll decide on your own when you start doing this for yourself. So for our purposes, like I said, we'll round up first and then double it to get the other end. Any questions? Well, what's that? The other thing we need to be able to do is we need to find the overall exterior wall sheathing. Now, assuming we have an 8-foot wall. Now, 8-foot wall is really how tall? 8 foot 1 1/8 inch, right? You guys know where the extra inch and an eighth comes from? No? When you're doing your ceiling sheetrock, you use 5/8 inch sheetrock on the ceiling, right? Then on the wall, you use 2 4-foot pieces of sheetrock on the wall going horizontally. So that's 8 foot and 5/8 inches. The extra half inch is you always leave a half-inch gap between the bottom of that bottom sheet of sheetrock and the floor. For a couple of reasons. One is in case there's any slight unevenness, and two, if the floor gets wet, it doesn't immediately hit the bottom of the sheetrock, because sheetrock does wick water, and if it gets wet, it does mildew. Sheetrock gypsum is a source of food for mildew. If you guys talk about mildew or mold control, there are 2 things that are required: moisture and a food source. And both wood and sheetrock are food sources for mildew. Green board?
Yeah.
Green rock? There are some places now where you are required that your bottom plate of any stud wall is a blue board or green board, a mildew resistant board. Personally, if it's on sale, there's 3 levels of sheetrock. There's standard sheetrock. There's called a basement board that's slightly mildew resistant, slightly moisture resistant. And then there's the blue or green rock that's rated for bathrooms. In many cases, your basement board's only 50 or 60 cents a sheet more. In a lot of cases, I would just use that for the whole walls. Your ceilings usually aren't. I've seen more problems in ceilings, I guess, than anywhere else because of venting problems in the attics. But I mean, you could do all sorts of. There's always a step up you could do that's better than what you do, but there's a cost to benefit thing. But yes, there are a lot of places that do require that the bottom plate of a stud wall is now a blue board, a mildew resistant board. Green treated does not resist mildew, by the way. Green treated resists deterioration from water, but does not resist the growth of mildew. They actually use a blue board that has a slight zinc treatment in it. So anyway, you have the 8-foot 1 1/8 inch wall. A lot of times you'll have a truss as a slight heel height to it. In fact, most houses now are required to have what's called an energy heel or a type A heel on it, which means from the top of the stud wall or the bottom of the truss to the top of the top cord must be at least 6 inches for insulation. Some places are requiring more. Otherwise, you use a common heel that's only like 3 3/4 inches or 4 1/8 inch, depending on your slope. That's only 4 inches of insulation on the very outside of your attic. And you recommend, anybody know how much insulation you recommended to have? 12 inches is your recommendation for an attic now. So obviously you got 12 inches out here, and you cut down to 4 inches out at the top of your exterior wall. There's a big heat loss there. So in order to raise that up to have a heel on the end of your truss, what it is the heel. Sometimes it's just the bottom cord being cut different. Sometimes there's actually an upright in there. You're going to want to sheet up into that too, a ways. So we also have a floor. The minimum thickness of your floor is going to be 13 inches usually. 11 7/8 eye joists plus a 5/8. 5/8 to 3/4 tongue groove. I personally don't use anything less than 3/4 tongue and groove. If you have floor trusses, you're going to have 16 to 28 inches. For our purposes, what we are going to do is we're going to take nominal wall height. So in other words, it's not going to be 8 foot 1 1/8. It's just going to be 8 foot plus 1 foot for floor. That's kind of cheating, but we're going to make up for it, and we are not going to account. No deductions for doors and windows. That's very realistic, actually, because in real life, you're going to just sheet over everything and cut out the doors and windows later, so those pieces are going to be waste. Well, a lot of times what people will do is they will run the sheet up. Let's say your sheet of plywood or your sheet of OSB comes up to here. Your first sheet, if you go down to the bottom of your floor, right? So you've got it like 12 or 13 inches up here. They'll leave that until they cut out the doors and windows. And then they'll square up the doors and windows, and they'll use some of those pieces up there sometimes. But most of the time, putting in those little pieces is more of a pain than it's worth. Just using plywood, and those scraps for the doors and windows go in the scrap pile. I've built a lot of shelves in my basement through the years with scrap OSB from job sites. So anyway, our exterior sheeting, number of sheets, is going to equal the perimeter of the house times wall height plus 1 divided by what? 32. They do, by the way, make 4 foot by 9 foot sheets of OSB that some people like to use. They do make 4 foot by 10 foot sheets of OSB that some people like to use. Not pleasant to work with, really.
No, we had a house once and didn't realize we were fixed out the tree saw.
Oh, sure.
And didn't realize it was 4 by 9, just assumed it was 4 by 8 by measuring.
Yep.
Ordered it, something wrong.
The other thing you do have to be careful of, when you look at the back of a sheet of OSB, if you order, after familiar materials, when you do walls of a house, you usually order 7/16 inch sheets, thickness sheets. If you look at those sheets, there'll be a dark line down the center, and lighter lines like that. Or a light line down the center and darker lines beside it. When you do a roof, you usually order 1/2 inch OSB. Look at the 1/2 inch OSB, there's lines like that. Most people do not realize, don't think there's a significance to this. Now, there are some OSB that have lines going in both directions. You get the cheap stuff from Menards that will have both directions. OSB, anybody know what the letters OSB stand for? Oriented strand. Good. I'm glad that you got that one by this point in the semester. Oriented strand, but oriented is the very important word there. The strand, the fibers are oriented for strength. They're oriented in a single direction. If you have lines going both directions, that means that there's a random orientation, and they're usable in pretty much either direction, but they're not as strong as the ones that are fully oriented. The ones that are like this, usually 7/16 with the lines the long way, they are oriented. They should be standing upright because their strength is in the other direction. Their strength is side to side so that they actually will hold the shear of the walls and hold the studs in place. If you lay those sheets on their side, they're not nearly as effective. Yeah, the
pieces are mostly glued up and down right way.
Yep. They've got their strength and they have to be used in that orientation. Now, there's the second reason why they use 1/2 inch sheeting for a roof is if you use 7/16 inch sheeting, even that little 1/16 inch of thickness is going to make it really spongy when you walk across it. Technically, I always use 5/8 inch sheeting on roofs because I'm uptight and I'm fat. And when I walk across even 1/2 inch, I can feel the cushion, especially if you step on a seam, even with the H-clips in it.
Yeah, you said right at the top, and you get that little strip.
Yeah, you get that little, a lot of times you end up with like a 6-inch strip on the top, and that's always terrible. I never use H-clips on those strips, by the way.
No?
On those little strips, I will always take a scrap piece of 2x4 and put behind them. That gives them a lot more strength. So anyway, in your packet, there is page 320, where you asked to find the number of studs and number of sheets. So I'm going to have you find there. For B, actually, A is on the front side, so that starts on page 319. Problem 2, A through D. So you only have to do problem 2 there, and you only have to find the number of sheets and the number of studs needed. Next, on, where are you? All the way in the back here? I guess so. On page 330 through 331. This is problem 6. A through C, it looks like. I want you to find number of exterior sheets required. Now they actually do give you the roof, so you do have to do the gable ends and add in the gable ends to that. C, you can see, is a hip roof, so you don't have any gable ends to add in, except there is one gable end to add in on that one, if you'll notice. You guys know how to read the top view, like on page 321 for number C there. That top view, those little triangles are showing its hip ends. There's no gables on those two ends of the house, but the third end there in the corner, the top, upper left end, there is a gable end there to do. And I want you to try, we didn't discuss it, and I will say I won't quiz you on it, but I do want you to try to find number of sheets of sheetrock. I want you to do the sheetrock in 3 pieces. Piece 1, I want you to do the exterior walls. Obviously, it's the inside surface of the exterior walls. 2, I want you to do ceilings. So inside surface of the exterior walls is just going to be like doing the exterior sheeting. You find the surface of the wall, you divide by 32. You're not going to deduct for any interior wall intersections or anything like that. You're just basically planning as though you're framing the whole inside of the exterior walls. Same for the ceilings. You're not going to deduct for any walls there. Believe it or not, I actually do know crews that will put up a house with no interior walls, and they will sheetrock the inside of the exterior walls and the ceilings before they put up interior wall partitions. Makes a lot of sense, actually. Especially if you have houses, if you're doing row houses. You ever seen the communities that are, all the houses look the same? They do that a lot there because the electrical crews can come in, they just pull the wires in the exterior walls. The crew comes in, sheetrocks the exterior walls and the ceilings, and they've got the wires hanging out of the ceilings for the interior walls. When they go in, they can just slap them right in. It's really a neat, a fast way of doing it. A lot of disadvantages of doing it, though, if you're doing a custom home, which most of you are probably going to do. Partly because one of the ways to add outlets and stuff in a custom home, you go up top and you can see the top of the stud wall, so you know where you drill a hole and run a wire down through. You don't have that advantage, obviously. The third one, and again, this one you probably is going to be a little bit more of a guess on your part because we didn't go over this at all. So the interior walls. I just want to see what you can come up with on the interior walls. Exterior walls and ceilings you should be able to come out really well on. The interior walls is just kind of playing around with for now. Okay, well, that ends our first hour.